Hello, my name is Jonathan Sullivan, and today we'll be looking at matrices and some of their properties. First, we'll go over what a matrix is. Second, we'll cover the trace of a matrix. Third, we'll look at how to calculate the determinant of a 2 by 2 matrix and also the inverse of a 2 by 2 matrix. So buckle in and let's have some fun. All right, so first let's talk about what a matrix is. A matrix is literally just algebraic structure that we can use to group numbers or vectors, depending how you look at it. So we denote it by two brackets, and we call this matrix B. And we can just put some numbers here. So we have 2, 1, 0, and 4. So when we talk about a matrix have different sizes. So the size of this matrix would be a 2 by 2 because we have 2 rows and 2 columns. We could also have a matrix that was a 3 by 2. So this is an example of a 3 by 3 matrix. Other important things about matrices, let's look at something called an identity matrix. So an identity matrix is going, well, before we get there, let's talk about what a square matrix is. So a square matrix is a matrix where you have the same number of columns as you do rows. So this right here, this would be a square matrix. This wouldn't be a square matrix. So if we talk about an identity matrix, it has to be a square matrix. So I do a 3 by 3. So in identity matrix, along the diagonal, we're going to have 1s, and everywhere else we'll have 0s. So this would be a 3 by 3 identity matrix. Obviously, you can have, n by n, 2 by 2, 4 by 4, 6 by 6, and just like the 0 is an addition of regular numbers, stands for the identity, or 1 when you're multiplying. Here this represents the identity in matrix multiplication. So we won't cover that today, but if I was to take a matrix and multiply it times this matrix, it would give me that matrix back. So if we have matrix A, and I can just write that, matrix A times this identity matrix, that would just give me matrix A back. All right. So I know you guys are probably wondering, how do I write this stuff? So I'll give you an example. I'm just gonna log on to try to think of a good IDE online that I can use. Trinket. All right. this should work. So let me go ahead and share my screen. Or actually, let me use REPL. I'm going to use REPL. But you guys should be able to see this. I don't want to sign up right now. Okay. So it's just an online Python interpreter. I wanted to kind of show you what a matrix looks like in Python. So in Python, we represent matrices as list of lists. So for instance, let's have a 2 by, can't do that, matrix. I'll just say 2 by 2, like that. First, I'll just make a list. And then inside of there, I will make 2 more lists. So this first list represents the rows. So I can just put some numbers here. And so this first list, this would be row 1. When I write it, I like to line them up like this. That way they kind of look like a matrix a little. And we just put some numbers for the second row. So I could also have, let's say, identity. I use I. And make this a 2 by 2 also. Again, start with a list, and then we have a list of lists. And here, remember, our identity matrix just has 1s across the diagonal. So in this case, 1 0 0 1. All right, so let's print these. All right. You can see here, we have our matrices, and I guess we could make a function, let's say make print matrix. And we can use this function for row in matrix. So we can just write this function to help visualize these a little more. It's just for space. Just give it some space under it. All right, that looks good to me. We have our 2 matrices here. So next, I told you that we were going to talk about the trace of a matrix. Well, the trace of a matrix is actually a little simple. We just look at the diagonal components of a matrix. 1 second. Right, we just look at the diagonal components of the matrix and add them up. So we can make a function for that. We'll call it trace, and it takes in a matrix. And remember, you just want to go through the matrix And actually, so there are a few things here. The trace matrix has to take a matrix, or the trace of a matrix has to use a square matrix. So let's go ahead and check that. So we could say if n, let's say length of our matrix doesn't equal the length of the first row of the matrix, then we know that this is not a canvas, so we could raise let's say value. So this just checks to make sure that we have a square matrix. Next, we could say, well, or actually, here we could say I equals 0, just to start off, and while I is less than, or you know, I'd rather use a for loop. So let's say for I comma, which would be our index, and then let's say value. And actually, since we're going to be going through the rows, let's say row index and value, which will actually be the row itself, and matrix. Then we're going to use enumerate, that way we get a tuple. The actual index. Then we say for a column index this time, and then here we get the value. Enumerate row. Then we say if our I equals CI, and that's because we only want the diagonal. So when the row position equals the column position, let's make a variable here called results, our accumulator. So when this happens, we'll set this to 0. So when this happens, we want results to we want to add the value of the matrix at that particular position. So 0, 0, 1, 1, 2, 2 to our results. All right. At the end of this function, we can just return our results. All right, so let's just kind of walk through this by hand. So the trace of the first matrix is going to be 23 plus 84. I can do that in my head. 84, 85, 86, 87, then 97, then 107. So we should have 107 for the first matrix. So let's print trace of our first matrix. All right, we have 107. And then we should also have 2 for our identity matrix, because just 1 plus 1. All right, so that looks good. Let's go ahead and look at the transpose of a matrix. So